In this one, I'm going to prove this statement. All right, so the if part, the if part is all of this. This is what we assume. This is what we want to show. Remember, to show that A equal B, we really show that A is a subset of B and B is a subset of A. All right, so there's two things to prove. One, A is a subset of B. Two, B is a subset of A. So one, we're going to show that A is a subset of B. Remember that this is really an if-then statement. So we show or prove. Let me write that, prove, same thing. So I prove that. Right, remember when we're trying to prove an if-then statement, we can assume this. We can make that assumption. Why can we assume this? Well, because if it's false, then the whole thing's true anyway. So assume X is an A. Okay. So now the idea is we're going to use this piece right here. Now the problem is that elements of A cross B, right, it has ordered pairs in it. It doesn't have just X in it, but we just have X right there. But we can get around that because we know that B is not empty. That's also an assumption. All right. Since B is not empty, there is something in there. There's something in it. Now, we don't know what that thing is. This is a totally general proof. We don't really know what that thing is, but let's just give it a name. Since B is not empty, there's something in it. Call it Y. Call it Y. Okay, so Y is in there, right? So Y is in B, X is in A. So XY is in A cross B. Now we can use the assumption. Since A cross B is the same as B cross A, and we know XY is in A cross B, XY is also in B cross A. Now break it down. Now break it back down. if xy is in B cross A, that says that x is in B and y is in A. So x is in B. You see, we showed that. We assume that there. And we showed that there. We use our assumptions to build up to xy being there, so we can use that to put xy there. See, x will be in A there. Now x is in B there. Okay, so now let's prove 2. 2 is entirely similar. But so now we're going to prove B is a subset of A. All right, so now our assumption is not that x is in A. Now our assumption is that x is in B. Now since A is not empty, there's got to be something in it. Let's call it y. So yx is in A cross B. Let's see, x was in B, so that makes sense, and y is in A, so that's right there. So then now xy is in B cross A. Let's see, y was in A, right, okay, so then these change here. X is in B, so now x is in A. And that's the proof. Let's see, let's check real fast just to make sure we got all this correct. B is a subset of A, so x is in B. B is a subset of A. Okay, so proving x is in B implies x is in A. Suppose x is in A. Since A is not empty, there's something in it, we'll call it y. So y is in A, right? Y is in A, so that makes y is there, x is there. Okay, that looks good. Since those are equal, then you flip it around. Yx, x turns into xy. No, yx, so no, okay, that's right, my mistake here. This should be yx. Yx there, right? So y is in B and x is in A. But the thing to notice is that both directions are entirely similar. They're almost exactly the same. And just rearrange the things. If you make all the B's into A's and all the A's into B's, and then everything's exactly the same from 1 to 2. So this is where, in a real proof of this, someone might just say, for part 2, they say entirely similar.